guys, so today we are solving the GFG POTD Padovan sequence. What the problem statement say is given a number n, find the nth number in the Padovan sequence. Okay, so we are given n and there is a Padovan sequence. I think it is pronounced as Padovan sequence. Okay, what is a Padovan sequence? A Padovan sequence is a sequence which is represented by the following recurrence relation: P of n is equals to n minus 2 and n minus 3, and the first three elements are 1. Find 0, 1, 2, 3, 4. This is zeroth position. This element is also 1. This element is also 1. This element is also 1. Now, for n is greater than 2, my element is the summation of the second last element and third last element. Second last element is this element and third last element is this element. Now this becomes 2. After that, I comes to my index 4. Then what is the element at the index 4? Second last element is this, third last element is this. So my fourth element is also equals to 2. Now comes to the fifth element. Fifth element is equals to the second last element sum. So this is equals to 3. Now comes to sixth element. Second last elements are 2 and third last element is 2. Then equals to 4. Okay, that's how this the Padovan sequence is look like. Okay. Now, since the answer can be very big, print the modulo, so we have to mod the answer. Okay, let's see. If n is equals to 3, then answer is equals to 2. Okay, n equals to 3, then answer equals to 2. If n is equals to 4, then also answer equals to 2. You can see that. Okay, then what I will be doing is you can use the recursion. Also, first way is to use the recursion. Simple recursion. Okay, recursion. Then the time complexity of this recursion is big order of n, because you are traversing for the whole sequence till 0, and the space complexity is also becomes big order of n if of the recursion stack space. Recursion stack space, okay, it will take the big order of n, but we are expected to and the second is you are using the iterative approach to do this. Iterative approach means you are traversing for in the loop, so that the time complexity of this algorithm also becomes the space complexity is the if you are using vector. And the third is the most optimal way, that this algorithm is the time complexity is big order of n and the space complexity is big order of 1, because we are only storing this the second last element and the third last element. Let's say it's 2l and 3l, third last element and the last element. Let's say l. L is the last element, means the I minus 1th element. Third is the I minus 2th element, and the second last element is I minus 2th element, and this is I minus 3 element. Okay. Okay, then after moving up, currently I'm the ith index, then this will denote like this. When I will move my I to I plus 1th index, then what will I do? I will simply assign my last to my second last, my current index to my, okay, I will assign last to my current index, but I will not do this. Firstly, what will I do? I will simply assign my third last to my second last, then my second last to my last, and then then I will assign my last to my ith index. Okay, and then I will move my I to the next I to I plus 1. Okay, and simply for every I will be summing up my previous two elements, means second last element and third last element, which is my current element. Okay, and after the whole algorithm ends, my current element is equals to my answer. Okay, what is the time complexity is big order of n, space complexity is big order of 1, because we are using only integers to store the element. Okay, now let's talk about the code. So firstly, I will initialize my last is equals to 1. Then I will initialize my second last. Okay, second is equals to 1. Then I will be assigning my last third is equals to also 1. But if my n is equals to 0, or my n is equals to 1, or my n is equals to 2, then I will simply return 1. Okay. Then what I will be doing is I'm traversing through the I index I equals to 3, comma I less than or equals to n, comma I plus plus. Then my current element and the current element, okay, is equals to something else, okay, like 0. Now my current element is equals to my second last element, okay, second last element plus my second third element. Then what I will be doing is at the end of this I will return my current element, and then what I will be doing before moving to I plus 1, I will assign my third last element to second last element. I will assign my second last element to third last element. I will assign my second last element to my last element, and I will assign my last element is equals to current element. Okay, that's how it can be done. Let's run it. If it is working fine or not, let's see. Okay, it is working fine. What is the time complexity? This loop is running for big order of n time. Then the time complexity of this algorithm is big order of n, and the space complexity of this algorithm is big order of 1 because we are not using any extra space instead of these integers. Okay, and this is also same as the problem statement you can see here. Okay, let's submit it. Okay, we have forgot the moduling. Int mod is equals to 29 plus 7. Here I will assign control Z mode. I will assign mode here. I will assign mode here. I will also assign my mode here. Okay, let's run it. Submit it. Okay, working perfectly fine. So this is all about the Padovan sequence. Thanks for watching. See you tomorrow.